This is your second Sig Test of the year. So the directions are to solve for x. We're going to try and isolate x by itself in each one of these different pieces. We'll go by one and doing that in each piece. So for this first one, we have a logarithmic function. So in order to isolate x or to solve for x, we will get the logarithm by itself first. So in order to do that, we have to subtract 4 from both sides. So we have y minus 4 equals 3 log base 2 of x minus 1. And then divide by 3 on both sides. So we have y minus 4 over 3 equals log base 2 of x minus 1. So now that the logarithm is isolated by itself, we can get rid of it by putting it into exponential form. Now for students who had my class, I've taught exponential form or converting to exponential form as the wraparound. So if you start with the base, it'd be 2 to the power of the left-hand side of the equation equals what's left over right here. So if we rewrite that in exponential form, we get 2 to the power of y minus 4 divided by 3, and that's all up in the exponent, equals x minus 1. And then last but not least, we're going to add 1 to the other side. And that should not be in the exponent, so that should be standing alone on its own. So we get x equals 2 to the power of y minus 4 divided by 3 plus 1. And that's how you isolate x for the first one. Again, you might not see the merit or the point in doing that yet, but it will become apparent as time goes on that you need to be able to isolate a single variable based on any different function. So it's important to know how to do that given whatever function we're working with. So this is how you isolate a variable when we're dealing with logarithmic functions. Let's look at how you isolate a variable when we are dealing with trigonometric functions. So let's look at part B. So let me erase all this. Cool. So for part B, just like we did in part A, we also need to isolate the trigonometric function. So let's divide by 5 on both sides. So I have y divided by 5 equals cosine inverse of 3 plus 2x. Notice that I left some room right here in front. That's because I'm setting myself up to take the cosine of both sides. So now that my trigonometric function is isolated, if I want to get rid of this cosine function, notice that it's cosine inverse. So if I want to get rid of cosine inverse, so I take cosine of both sides, so cosine of the left-hand side and cosine of the right-hand side, then these cosine and cosine inverse will cancel each other out. So that's the point of taking cosine of both sides. If it was cosine of this, to get rid of that, I would have taken the inverse cosine of both sides. So either way, it's fine. You can just leave it like that. That's how you move the cosine over to the other side, however. So I have cosine of y divided by 5 equals 3 plus 2x. And then hopefully it's pretty clear here how you isolate x. So subtract 3 and then divide by 2. So if I can just do that all in one step, if that's okay with you guys, I'll have cosine of y divided by 5 minus 3, and then the entire thing is divided by 2 equals x. So if you're confused about that last step, please feel free to come talk to me about it, but hopefully that last one makes sense to you guys about how we solve for that. So x equals cosine of y divided by 5 minus 3 divided by 2. And then last but not least, we have a rational expression. Now, the tricky part about this is that it has an x in the numerator and denominator, so it's located in 2 places. So in order to solve for x or to isolate x in this problem, it's a little tricky in the sense that you kind of have to manipulate the equation a little bit. So let me show you what I would do, and then we can kind of go forward from there. So let me create a little bit more room for us by erasing that. So in order to go forward from here, my goal is to get x in only one place. And so I'm going to show you how we're going to do that when you have an x on top and bottom. So first things first, we're going to get rid of the denominator on both sides by multiplying by the denominator. So multiply by 3x minus 4 on both sides. Notice that on that side, if I do that, those cancel because we're multiplying and dividing. On the left-hand side, we have 3x minus 4 times y, so I'm actually going to distribute that y to both of these terms. So we get 3xy minus 4y equals, and then whatever's left in the numerator on this side of the equation, which is x plus 2. Now, I still have x in two places. I still have x here in this term, and I also still have x here. So in order to get them in one term, I'm going to try and bring them both to one side of the equation and push everything else to the other side. So let me start by subtracting x from both sides and adding 4y to both sides. So I can push that 4y to the other side since it does not have an x in it. So I have 3xy minus x equals 2 plus 4y. Now, I still have an x in two places, but at least now they're on both the same side of the equation and everything else is on the other side. These are not like terms, so you can't necessarily just add them straight up. However, we can factor out an x. So if I take an x out of both terms, because it's the GCF, I get 3y minus 1 times x equals 2 plus 4y. And then last but not least, now I have x in only one place. This is the only place I have x now. So I can divide by this remainder over here, which is 3y minus 1, and that will allow me to have x all by itself. So my final answer is x equals 2 plus 4y divided by 3y minus 1. And now x is isolated all by itself. So that's how you isolate x in each of those three individual pieces. And how you would solve for a variable given three different functions.